Hey y'all, in this video we will continue practicing solving trig equations such as these crazy guys. As I do this, I'm going to be making the assumption that you know this set of information. You should have either memorized these or you should be able to generate this chart within a minute. Also, your Pythagorean identities, you should know these. The ones in yellow you have to memorize for sure. The blue and pink can be derived quickly. So look, just be able to generate this chart in under a minute. So looking at number 7, we have secant squared minus 1. I think, is that on the chart? Let's check the identities. Okay, we have secant minus 1. Okay, I mean, I could solve this by adding 1 to both sides, or I could do the substitution and use tangent. It's really, I could go either way. Maybe I'll solve it both ways real quick. If I added 1 to both sides, then that will give me secant squared x is equal to 1. Then I could take the square root of both sides, but be careful, whenever you take the square root of both sides, the solution will be positive or negative. Okay, so that unsquares this. So now I have the secant of x is equal to positive or negative 1. Now, since secant and cosine are reciprocals of each other, then the cosine of x should equal plus or minus the reciprocal of this. But the reciprocal of 1 is still 1, so we're good. And so cosine, the cosine of what angle is 1 or negative 1? Let's see, so quadrantal angles, of course. So here I have 1 comma 0, 0 comma 1, negative 1 comma 0, and 0 comma negative 1. Cosine is the x value. Where is the x value, positive 1 or negative 1? Well, it's positive 1 here, it's negative 1 there. I want all that good stuff. But that's it. So those are the angles that we got. Okay, so these are the solutions. X equals, so this angle is 0 and this angle is pi. By the way, go with 0 instead of 2 pi for this lesson, because that's how we defined it in the directions. So 0 and pi. So that's it. These are the two solutions to number 7. Now, I had talked about doing it with tangent squared, but you know what? I don't have time for that. I'm just going to keep going for now. Okay, number 8. Now I got secant, cosecant. You know, I have a couple of ideas. If I brought that over, I could factor it out. Maybe I'll do it that way. I was thinking about rewriting both of these in terms of sine and cosine, but I'm wondering what would happen if I subtracted 2. Oh, man, couldn't write it down. Let me try that again. I wonder what would happen if I subtract 2 cosecant x from both sides. Okay, I'm curious, so I'm going to pursue this. Okay, so right now what I have is I've got secant x, cosecant x, and then here comes the minus 2 cosecant x is equal to 0. Now, I have cosecant in both terms here, so that is a GCF. So what I could do is I could pull the cosecant x out front, outside of the parentheses. And if I take those away, then that's going to leave me with secant x minus 2 is equal to 0. Now I could use the zero product property and set cosecant x equal to 0. And I could also set secant x minus 2 equal to 0. Okay, now cosecant and sine are reciprocals of each other. So if cosecant is equal to 0, then sine would have to equal 1 over 0. Okay, but of course this is undefined, which means that cosecant x is also undefined. Alright, so this will not yield any solutions. So I'm just going to throw that out. Cosecant cannot equal 0. Just like sine x cannot equal 1 over 0. Alright, hopefully we will have better luck on the right hand side. Okay, erase. Okay, secant. Let's work this side. Maybe we'll get at least one solution. Adding 2 to both sides, I have secant x is equal to 2. Secant and cosine are reciprocals of each other. So if secant x is equal to 2, then cosine x should equal 1/2. Okay, because they're reciprocals. They're both reciprocals of each other. Okay, so I'm going to work with this version. All right, cosine must be equal to 1/2. So cosine of what angle is equal to 1/2? You should have memorized that that is pi over 3. That tells me that pi over 3 is my reference angle. So I'm just going to draw a quick picture of pi over 3, which looks like this. Okay, these are pi over 3's. Now there are 4 angles that have a reference angle of pi over 3. Okay, the cosine of these two will be positive. The cosine of these two will be negative. Alright, because cosine is the x value on the unit circle. Positive to the right, negative to the left. In this case, we want a positive 1/2, so these two angles will be the solutions. Okay, so x is equal to pi over 3, or 5 pi over 3. Okay, so only 2 solutions to this equation. Alright, so that was number 8. Let's go on for number 9. Alright, cosecant. Let's just go ahead and get cosecant by itself. So if I divide both sides by 3, then that is going to give me cosecant squared x is equal to negative 4 over 3. This makes me very uncomfortable because I need to take the square root of both sides. But if I take the square root, I'm going to get imaginary numbers. So that does not seem okay. So I feel like this has to be no solution because of the negative. Yeah, I'm just going to go ahead and commit to it. No solution. Okay, that's the first one of those that has shown up in any homework. So it was throwing me a little bit, but there's no way you can square something and have it come out to be a negative answer. You know, this, if I had kept going with this, the next thing I would have had negative 2i. Well, not negative 2i. It would have been plus or minus 2i over radical 3. You can't have imaginary numbers. Anyway, let's keep going. All right. This one I see that we have cosine and we also have sine. So I'm going to do a substitution so that I have all one type of trig function. And I need to work with the one that's squared because that's what's on my chart of Pythagorean identities. Cosine squared equals 1 minus sine squared. Okay, so I'm going to take this cosine squared and replace it with 1 minus sine squared. Okay, notice that this one is not squared. So now I'm going to get 0 on one side and see what happens. So for starters, I will subtract 1 from both sides. Those both cancel. That leaves me with negative sine squared x is equal to negative sine x. Time to add sine x to both sides. So that's going to give me negative sine squared x plus sine x is equal to 0. Now when I'm factoring, I don't like having a negative in the front. So what I always do is I divide everything by negative 1. Alright, I just like my leading coefficient to be positive when I'm factoring. So that changes all the signs. So now I'm going to have positive sine squared x minus sine x, and 0 divided by negative 1 is still 0. So sine x is the common factor. So I'm going to take that sine x and put it in front of parentheses. So that will leave sine x minus 1 inside the parentheses. So 0 product property. I will take sine x and set that equal to 0. And then I will take sine x minus 1 and set that equal to 0. Adding 1 to both sides, I get sine x equals 1. Okay, so the sine of what angle is 0? The sine of what angle is equal to 1? The answer to both of these sound like quadrantal angles. So let's do our quadrantal angle analysis. Okay, so here I have 1 comma 0, 0 comma 1, negative 1 comma 0, and 0 comma negative 1. Sine is a y value on the unit circle. So where is the y value equal to 0? There's 1 and there's 1. So far we have 2 solutions to write down. Alright, we have x equals 0 and pi. So we have 0 and pi. Now, what about sine equaling 1? Okay, maybe I'll just change the color of my highlighter. Where is the y value equal to 1? So well, there's a y value of 1 right there. So I'm going to add that to my list of solutions. That's pi over 2. So there you go. These are my 3 solutions to this equation. Okay, that was problem number 10. That means it's time for problem number 11. Interesting, interesting. Whenever I see that I have the same thing in more than one term, I think about taking out the common factor outside of parentheses. So that's going to be my strategy now. If I factor out the GCF here, the sine x, alright, which appears here and here, if I take that and I put it out front, okay, then let's see. So that's out front. So right here where the sine x was, I'm going to have a 1. Now this is gone, but I'm still going to have minus 2 cosine x. Okay, so this is great. So I can use my zero product property and just set each factor equal to 0. So I can set sine x equal to 0, and I can set 1 minus 2 cosine x equal to 0. This one needs a little solving. Subtracting 1 from both sides. So I have negative 2 cosine x is equal to negative 1. Dividing both sides by negative 2 will give me cosine x is equal to positive 1/2. A negative divided by a negative is positive. Okay, time to find some solutions. So looking at this first little equation, sine of what angle is equal to 0, that should be answered by a quadrantal angle. So here's my quadrantal angle diagram. Alright, 1, 0, 0, 1, negative 1, 0, and 0, negative 1. Okay, sine is a y value. So where is the y value equal to 0? I don't feel like doing green right now. The y value is going to equal 0 here and here. So that gives me two solutions so far. Alright, so far I've got x is equal to 0 and pi. These are the two angles where it's happening, 0 and pi. Now, what about cosine of what angle is 1/2? Now, you should have memorized that the cosine of pi over 3 is 1/2. Okay, that tells me that the reference angle is pi over 3. Okay, so I'm going to just draw a quick little diagram of pi over 3. Okay, so these are the four angles that have a reference angle of pi over 3. The cosine of any of them will give me some kind of 1/2, but these two will be positive 1/2, and these two will be negative 1/2, because cosine is the x value, positive to the right, negative to the left. Since we want positive 1/2, then these two angles are the solutions. So we just need to add those to the list. So this is pi over 3. And this is 5 pi over 3. So these are the four solutions. Okay, let's do one more problem on this video, and then we will call it a day. Okay, wow. What you cannot do is divide both sides by cosine. You can never, ever, ever divide by a trig function, so put it out of your mind. What I will do is subtract cosine from both sides, getting 0 on one side. Okay, so that leaves me with cosine cubed x minus cosine x is equal to 0. Let's do the GCF, alright? I see the common cosine. So taking out cosine x, that is going to leave me with cosine squared x minus 1. Now I will do my zero product property. Okay, so cosine x is equal to 0, or cosine squared x minus 1 is equal to 0. This is already solved, but let me deal with this over here. So adding 1 to both sides will give me cosine squared x is equal to 1. Now taking the square root of both sides will give me cosine x is equal to plus or minus 1. You know what? Now I feel like I should show it. This is me taking the square root of both sides. Don't forget your plus or minus. Square root of 1 is 1, so that's why I just have plus or minus 1. Okay, so I have really 3 equations here, but it's all looking like quadrantal angles to me. Alright, so here's my, I'm just going to draw one quadrantal angle diagram, because I think I can use it for all of this mess. So this is 1 comma 0, 0 comma 1, negative 1 comma 0, and 0 comma negative 1. Okay, let's start with this. Cosine is the x value on the unit circle. So where is the x value equal to 0? Alright, so I have this and I have this. So far that gives me 2 solutions to write down. Alright, that's that's pi over 2 and 3 pi over 2. Alright, let's write that down. So I have x is equal to pi over 2 and 3 pi over 2. Okay, that's what I have so far. But I'm going to switch colors on my highlighter and keep going. Okay, because we also want the cosine to be positive or negative 1. So the cosine is the x value on the unit circle. So that's going to be positive 1 would be here, negative 1 would be here. So that's 0 and pi. So in addition to what I already had, I'm going to add those angles to the list of solutions. So 0 and pi. So all 4 quadrantal angles are solutions then. Okay, that is it for this problem, and that is long enough for a video, so I'm going to stop it there. I hope it was helpful, and I will see you on the next video where we will verify identities such as this one.